take as much food as he was accustomed to eat at home. But the whole of the carbon thus introduced into the system is not consumed. The temperature of the air is too high, and the oppressive heat does not allow him to increase the number of respirations by actual exercise, and thus to proportion the waste to the amount of food taken. Disease of some kind, therefore, ensues. On the other hand, England sends her sick to southern regions, where the amount of oxygen inspired is diminished in a very large proportion. Those whose diseased digestive organs have in a greater or less degree lost the power of bringing the food into the state best adapted for oxidation, and therefore are less able to resist the oxidizing influence of the atmosphere of their native climate, obtain a great improvement in health. The diseased organs of digestion have power to place the diminished amount of food in equilibrium with the inspired oxygen in the mild climate, whilst in a colder region the organs of respiration themselves would have been consumed in furnishing the necessary resistance to the action of atmospheric oxygen. In our climate, hepatic disease, or those arising from excess of carbon, prevail in summer. In winter, pulmonary diseases, or those arising from excess of oxygen, are more frequent. The cooling of the body, by whatever cause it may be produced, increases the amount of food necessary. The mere exposure to the open air, in a carriage, or on the deck of a ship, by increasing radiation and vaporization, increases the loss of heat, and compels us to eat more than usual. The same is true of those who are accustomed to drink large quantities of cold water, which is given off at the temperature of the body, 98 1/2 degrees. It increases the appetite, and persons of weak constitution find it necessary, by continued exercise, to supply to the system the oxygen required to restore the heat abstracted by the cold water. Loud and long continued speaking, the crying of infants, moist air, all exert an decided and appreciable influence on the amount of food which is taken. We have assumed that carbon and hydrogen especially, by combining with oxygen, serve to produce animal heat. In fact, observation proves that hydrogen of the food plays a no less important part than the carbon. The whole process of respiration appears most clearly developed when we consider the state of a man or other animal totally deprived of food. The first effect of starvation is the disappearance of fat, and this fat cannot be traced either in the urine or in the scanty feces. Its carbon and hydrogen have been given off through the skin and lungs in the form of oxidized products. It is obvious that they have served to support respiration. In the case of a starving man, 32½ ounces of oxygen enter the system daily, and are given out again in combination with a part of his body. Curie mentions the case of an individual who was unable to swallow, and whose body lost 100 pounds in weight during a month; and according to Martel, a fat pig overwhelmed in a slip of earth lived 160 days without food, and was found to have diminished in weight, in that time, more than 120 pounds. The whole history of hibernating animals, and the well-established facts of the periodical accumulation in various animals of fat, which at other periods entirely disappears, prove that the oxygen in the respiratory process consumes, without exception, all such substances as are capable of entering into combination with it. It combines with whatever is present to it, and the deficiency of hydrogen is the only reason why carbonic acid is the chief product; for, at the temperature of the body, the affinity of hydrogen for oxygen far surpasses that of carbon for the same element. We know, in fact, that the graminivora expired a volume of carbonic acid equal to that of the oxygen inspired, while the carnivora, the only class of animals whose food contains fat, inspire more oxygen than is equal in volume to the carbonic acid expired. Exact experiments have shown that, in many cases, only half the volume of oxygen is expired in the form of carbonic acid. These observations cannot be gainsaid, and are far more convincing than those arbitrary and artificially produced phenomena, sometimes called experiments which, made as too often they are, without regard to the necessary and natural conditions, possess no value, and may be entirely dispensed with, especially when, as in the present case, nature affords the opportunity for observation, and when we make a rational use of that opportunity. In the progress of starvation, however, it is not only the fat which disappears, but also, by degrees, all such of the solids as are capable of being dissolved. In the wasted bodies of those who have suffered starvation, the muscles are shrunk and unnaturally soft, and have lost their contractibility. All those parts of the body which are capable of entering into the state of motion have served to protect the remainder of the frame from the destructive influence of the atmosphere. Towards the end, the particles of the brain begin to undergo the process of oxidation, and delirium, mania, and death close the scene. That is to say, all resistance to the oxidizing power of the atmospheric oxygen ceases, and the chemical process of eremacausis, or decay, commences, in which every part of the body, the bones excepted, enters into combination with oxygen. The time which is required to cause death by starvation depends on the amount of fat in the body, on the degree of exercise, as in labour or exertion of any kind, on the temperature of the air, and finally on the presence or absence of water. Through the skin and lungs there escapes a certain quantity of water, and as the presence of water is essential to the continuance of the vital motions, its dissipation hastens death. Cases have occurred in which, a full supply of water being accessible to the sufferer, death has not occurred until after the lapse of 20 days. In one case, life was sustained in this way for the period of 60 days. In all chronic diseases, death is produced by the same cause, namely, the chemical action of the atmosphere. When those substances are wanting, whose function in the organism is to support the process of respiration, when the diseased organs are incapable of performing their proper function of producing these substances, when they have lost the power of transforming the food into that shape in which it may, by entering into combination with the oxygen of the air, protect the system from its influence, then the substance of the organs themselves, the fat of the body, the substance of the muscles, the nerves, and the brain, are unavoidably consumed. The true cause of death in these cases is the respiratory process, that is, the action of the atmosphere. A deficiency of food and a want of power to convert the food into a part of the organism are both equally a want of resistance, and this is the negative cause of the cessation of the vital processes. The flame is extinguished because the oil is consumed, and it is the oxygen of the air which has consumed it. In many diseases, substances are produced which are incapable of assimilation. By the mere deprivation of food, these substances are removed from the body without leaving a trace behind. Their elements have entered into combination with the oxygen of the air. From the first moment that the function of the lungs or of the skin is interrupted or disturbed, compounds rich in carbon appear in the urine, which acquires a brown color. Over the whole surface of the body oxygen is absorbed, and combines with all the substances which offer no resistance to it. In those parts of the body where the access of oxygen is impeded, for example, in the armpits or in the soles of the feet, peculiar compounds are given out, recognizable by their appearance or by their odor. These compounds contain much carbon. Respiration is the falling weight and the bent spring which keeps the clock in motion, and the inspirations and expirations are the strokes of the pendulum which regulate it. In our ordinary timepieces, we know with mathematical accuracy the effect produced on their rate of going by changes in the length of the pendulum or in the external temperature.